What's going on, Alex Bros? It's Mr. C again, and in this video, we're going to do another inequality, but this time it involves a rational expression instead of a polynomial. In particular, solve for x over x minus 3 is greater than 5. What we want to do is make sure that one side of this inequality is 0, and we don't have a side that's 0 yet, but it's pretty quick and easy to do so long as you take this 5 over to the left via subtraction. That would give us 4x all over x minus 3 minus 5. And I want to put that over 1 for a particular reason, which I'll explain in just a second. Before we move on to that explanation, I want to pause for a moment and focus our attention on this inequality. It says greater than 0. So what we're really in the business of looking for here are values of x that make the left-hand side positive. That's what greater than 0 means, your value that's positive. Now, on the left-hand side, if you're subtracting two fractions such as this, you want to go ahead and combine them into a single fraction. So that means we're going to need a common denominator. Or as Anna would say, common denominator. But anyway, the common denominator here is x minus 3. So with my fraction 5 over 1, we're gonna have to multiply top and bottom by x minus 3. Let's clean that up a little bit. We're gonna have 4x over x minus 3 minus, and I'm gonna go ahead and distribute the 5 to clear parentheses, 5x minus 15 all over x minus 3. All right, and all that is still being set greater than 0. Let's go ahead and combine the tops together via subtraction. 4x, let's use parentheses here, minus quantity 5x minus 15. All of that on top of just only one copy of the common denominator, x minus 3. Let's continue with clearing parentheses on top so we can combine some like terms. We get 4x minus 5x plus 15 all over x minus 3. All right, almost finished cleaning this up into a single fraction. Let's combine like terms. 4x minus 5x is negative x. So negative x plus 15 in the numerator, and then x minus 3 in the denominator. Whew, we made it through the first hurdle, folks. All right. So we do have the left-hand side combined into a single fraction. That didn't change the fact that we still want values of x that make the expression positive or greater than 0. But where do we go from here? How do we decide on which values of x are going to make this fraction greater than 0? Well, one thing you want to do is figure out, are there any values of x that make the rational expression undefined? In other words, are there any values of x that create division by 0 in the rational expression? The easiest way to figure that out is to look at your denominator, which is x minus 3, and set that equal to 0, and then solve for x. So x equals 3. This creates division by 0. Even though that's a harmful number to plug into our rational expression, it's actually a helpful value in terms of figuring out which values of x make the rational expression positive. What you want to do next is set the numerator equal to 0 and solve for x. So in other words, negative x plus 15 equals 0. And when you solve for x, you get x equals positive 15. So having these two numbers allows us to break up the number line into what's going to be 3 different regions. And we'll test a value from each region to figure out which values of x make the fraction positive and which make it negative, and so on and so forth. So one value of x that we want to put on there is 3. The other value of x that we want to put on there is 15. Now, to figure out which values of x make the fraction positive, and at the same time we'll figure out which ones make it negative, we're going to do a little sign chart. So I'm going to set up a little table right underneath the number line diagram. Going to be 4 rows here, kind of a skinny row for row 1, and then some rows that are a little larger in size. And they're going to be 3 columns. All right, I'm going to put a 3 right there and a 15 right here. Now, to the left of this table, I'd like to put the parts of the rational expression and then the entire rational expression. What I mean by that is, to the left of row 2, the numerator of the fraction is negative x plus 15. To the left of row 3 is where I'll put the denominator, which is x minus 3. And then for the very last row, to the left of that, I'm going to put the entire rational expression, negative x plus 15, all over x minus 3. So now what we do is we pick some values from each of these 3 regions. I'll go in order from left to right. I'd like to look at the region that's to the left of 3. An easy value to pick from there to work with would be 0. And let's see what happens when we plug 0 into negative x plus 15. If you plug 0 into negative x plus 15, you get 15, which is a positive value. However, if you plug 0 into x minus 3, you get a negative value. So in terms of the entire fraction, which says, take negative x plus 15 and divide it by x minus 3, we would essentially be taking a positive number and dividing it by a negative number if 0 is plugged in for x. Therefore, the value of the entire fraction would be negative. So what that means for us is any value of x that's less than 3 is going to make the rational expression negative. Let's pick a value between 3 and 15. My mind is kind of heading towards 5, so I'll use 5. If we plug 5 into negative x plus 15, we get negative 5 plus 15, which is 10, which at the end of the day is a positive value. If we plug 5 into the factor x minus 3, we get positive 2, which again is a positive value. So in other words, if we plug 5 into the rational expression, we're taking a positive value and dividing it by a positive value, which of course we know gives us a positive value. So what that means is any value between 3 and 15 is going to make the rational expression positive. Now let's pick a value of x that's larger than 15. I think 20 would fit the bill for us, don't you agree? If we plug 20 into the factor negative x plus 15, that actually gives us negative 20 plus 15, which is negative 5. In other words, a negative value. If we plug 20 into x minus 3, we get 17, which is a positive value. So at the end of the day, if we plug 20 into the entire rational expression, we get a negative over a positive, which is a negative. So what that means for us is any value of x that's larger than 15 that we plug into the rational expression will make it negative. Let's keep in mind what we're really in the interest, really on the hunt for. If we go back up to this inequality, we want values of x that make the rational expression positive. So looking at our number line down below, we have a visual of what values of x make the rational expression positive, and it would be all those that are between 3 and 15. Notice the inequality symbol doesn't have a bar associated with it, so when we write out the interval notation, we'll use parentheses. But I do want to make a little comment. If the inequality symbol had a bar, which some will, you still would use a parentheses at least around x equals 3 because that creates division by 0. So long story short, any values of x that create division by 0, you're going to use a parentheses on by default, regardless of there being a bar or not involved with the inequality symbol. You don't want to include values of x that create division by 0. Otherwise, you get a huge Michigan pothole. Just kidding. All right, so we're going to form our final answer now. In interval notation, parentheses 3, comma, 15, parentheses. And this would represent, in interval notation, all the values of x that make the rational expression positive. All right, folks, thanks for gritting and bearing through a 10-minute video here. But, you know, that is all that's necessary to explain the solution to something like this. Of course, if you have any questions, feel free to reach out to me. Otherwise, thanks for watching, and I'll see you in the next video.